All right, guys, so here are 4 vocabulary words that I wanted you to look at, and we're going to define those. So first off, oh, sorry, give me a second. I want to show you that this is actually, it's on your Slick page. So if you were struggling with this, if you go onto your Slick page here and you go to our modules, and we go down to, we're in chapter 6. If you go to the very end, I don't know if you've seen this before, but it has a list of vocab words and definitions. So right here, chapter 6, key equations and terms. And it's going to be, you can download this, so it's a PDF. Let's actually look at that. And it's going to have some of those key phrases. So the first word, and equations, and the first one we saw that was consistent versus inconsistent. And I think, was that you, Spencer? You said inconsistent meant there was no solution. Well, that would mean, consistent means that there's at least one solution. All right, so that helps us with the first 2, okay? So if we're solving a system of equations and it has at least one solution, it's called consistent. System has at least one solution. Now, depending on your system, there could be 1 solution, there could be 2, there could be 3, there could be 4, and there could go on all the way up to there could be an infinite number of solutions. Now, inconsistent means that there is no solution to the system. All right, so now, let me go back. The next question was, what's the difference between dependent and independent? So dependent is a system of equations with an infinite number of solutions. Whereas if we go to independent, it means it has a single solution. All right, so dependent means that there is an infinite number of solutions. And independent means that there is a single solution. Now, I believe that when you were doing 6.1 and 6.2, it would have, on your homework, has this showed up, guys, where they would ask you, what kind of system is it? Someone unmute. Have you seen that on your homework for 6.1 and 6.2?
I didn't see it.
Okay, well, cool. I've seen it before sometimes. It's just good to know that. All right, now let's talk about 6.3. So in 6.1, we reviewed how to solve a system of equations that had 2 variables, 2 equations, and it was through elimination and substitution. If you did 6.2, which I really, really, really hope you did, that was where it jumps to a system of 3 equations and 3 variables, so x, y, and z. And then you learned how to solve that by getting rid of 1 variable and then just using the methods you learned in 6.1 to solve the system. What we're doing in this one is we're going to learn a different approach to solving systems of equations, and it's through a method called matrices. Now, I don't know if you've seen the movie Matrix or not. This is a fun little gift from it, but a matrix is just kind of a rectangular array of numbers, okay? And we're going to use those to help us solve systems of equations, okay? So first we're going to learn about how to write systems of equations as a matrix, and then we're going to do row operations, convert them into augmented matrices, solve them, and check your solutions. All right, so let's get started. Okay, first thing we need to know is what we did last time when we were trying to solve these was we eliminated a variable, and then we used the methods from 6.1 to use substitution elimination to solve for x, y. Our strategy here is going to be a little bit different. Our goal is to get the system of equation to look like this. This is called upper triangular form. So we want it so we have z solved for. Z is 1. No x or y. Now that's good because now y, notice x, y, and z, the coefficient here is 1. That's a big deal. Now notice I have z is -1. I could plug this in right here, and then I could solve for y. And then I've got y and z. And then I can plug in our solutions for y and z, and then I could solve for x. So our goal is to make it look like it's an upper triangular form, which is where our coefficient for the x, y, and z for the 3 equations are all 1, and there's nothing going on below them, okay? There's a bunch of zeros there. Now, this is kind of like a game. We've got 3 rules we can follow, okay, in order to do this. Number 1 is we can interchange the position of any 2 equations. All that's saying is that I can change rows. I can switch row 1, row 2, row 3, row 4, or whatever, okay? I can switch the rows. The second move we can do in this game is we can replace an equation with a non-zero multiple of itself. What that means is I could times a row by 2. I could divide a row by 3. I can multiply it or divide it by any constant as long as it's not 0. The one that we're going to use the most, though, is this last one. Is when we replace an equation with itself plus a multiple of another equation. And that sounds a little confusing. Let me show you what I mean by that, okay? We're going to do an example. So here is a system of equations. There is 3 equations, 3 variables. And the rule of thumb is as long as you have as many equations as you do variables, then you can solve it. Now, what we're trying to do here is we're trying to get this into upper triangular form, which is like this, what we saw on this page, okay? Now, to do that, we're going to use those 3 steps, those 3 rules that we found. We can switch rows, we can multiply or divide a row by a constant, and we can replace rows with multiples of itself combined with another row, okay? All right, so now let's look at this first one. What I'm going to do, and on with these, it's kind of like people like, I don't even know how to start. And really, it's the more you do it, the more you'll get the hang of it. But here's how I'm going to do this, okay? What I'm going to do first is I'm going to label these. This is row 1, this is row 2, and this is row 3. Okay? Now, what I'm going to do, and actually, you know what? I'm sorry. I'm going to erase that. I'm going to write it as lowercase, and you'll see why. Row 1, row 2, row 3. What I'm going to start off by doing here, guys, is I'm just going to switch row 1 and row 3. Okay? So I'm going to, and when you're doing this, it's really important you kind of label what you're doing, because it's pretty common for people to make just a simple algebra mistake or a simple like mistake with the sign, and you want to be able to go back and see what did I do here. So I'm going to put a little side note here. I'm going to switch R1 and R3. And if you're asking, why are you doing that? Well, remember, our goal is to get this into upper triangular form, which means I want to have just an x, no coefficient in front of it. If I look over here, I've got a 2 with the x's and a 3. Now, someone might say, well, why not just divide by 2, or why not just divide by 3? Well, then you get fractions, and no one likes fractions, right? All right, so let's rewrite this out now, okay? So I'm going to switch row 3 and row 1. So I get x minus y plus z is equal to 5. And then we get the second row stayed the same, 2x minus 4y plus 3z is equal to 16. And then that first row is now in the third row, so that's 3x minus y plus z is equal to 3. Now, if I make a mistake, I want you to just unmute and stop me. Don't wait until we get to the end or it'll be too late. Just stop me, okay? Now, what we need to do, if we're looking at upper triangular form, we want to get zeros right here. I don't want a 2x, I don't want a 3x, I want to get rid of those. So what I'm going to do is I'm going to think in my brain, what is the opposite of 2x? In other words, what could I add to 2x to make it become 0? And you would say you would add -2, right? So what I'm going to do here is I'm going to make a new row 2. And the way I'm going to do that, so if I'm making a new row, I write it capitalized. And if I'm using old rows, I use lowercase, okay? To get rid of that row 2, I need a negative 2x. So what I'm going to do is up here on row 1, I'm going to times row 1 by negative 2. So I'm going to do negative 2 times row 1, and then I'm going to add it with row 2. Because when I times this right here, this x by negative 2, it'll make it negative 2x, and then if I add it with 2x, it'll become 0, and that's helping me get it into upper triangular form. So let me write out what I mean by that, okay? So what I'm going to do is I'm going to take negative 2 and times it by row 1, and that's going to give me negative 2x, positive 2y, minus 2z, and that's going to equal it to negative 10. That's just row 1 times by negative 2, okay? Now what I'm going to do is I'm going to add that to our existing row 2, which is 2x minus 4y plus 3z, and that's equal to 16. When I add that together, negative 2x plus 2x is 0. 2y minus 4y is negative 2y. Negative 2z plus 3z, that's just going to be z plus z. And negative 10 plus 16 is 6. So what this means, guys, is that if I were to go and kind of rewrite the rows. So our first row is the same. I've got x minus y plus z is 5. But now we have a new row 2. Row 2, we have a 0 first, okay? So there's nothing going on there, so I don't have to write anything. I just have negative 2y plus z is equal to 6. So now I've got a 0 under the x. Perfect. Now, let's do that same thing with row 3. In row 3, we've got a 3x, and I need to get rid of it. So I'm going to think in my brain, what is the opposite of 3x? In other words, what could I add to 3x to make it become 0? And you would say negative 3x. So I'm going to also, while I'm at this, make a new row 3. I'm going to take negative 3, and I'm going to times it by row 1. And that will give me, and I'm still using this row, okay? So I've got negative 3 times x will be negative 3x, and if I add that to 3x, it'll give me 0. Then I'll add that to row 3. All right, now when I times row 1 by negative 3, I get negative 3x plus 3y minus 3z equals negative 15. All right, and then if we just look at row 3, that was 3x minus y plus z, and that's equal to 3. I'm going to kind of put a little line here so we don't get confused, okay? So now I'm going to add those together, and that's going to give me 0. 3y minus y is 2y. Negative 3z plus z, that's going to be negative 2z. And here, negative 15 plus 3 is negative 12. So now if I write that as my new row 3, I have 2y minus 2z is equal to negative 12. Okay, cool. So remember, our goal here is we want this to look like upper triangular form. I have an x up top and then nothing underneath it. And then on the second row, we have a y with nothing underneath it, and then just a plain old z. So where we're at right now is we got rid of everything under the x's. Our next step is we're going to try to get rid of this guy. We want that to become a 0. Well, just looking at it, guys, if we just add row 2 and row 3 together, that's going to get rid of that 2y, right? Because they're already opposites of each other. So I'm going to do that right off the bat. I'm going to make a new row 2. Or sorry, new row 3. That bottom row, I want a 0 under the y's. So to do that, I'm just going to take row 2 and add it with row 3. Doing that, currently row 2 is negative 2y plus z is equal to 6. And row 3 is 2y minus 2z is equal to negative 12. If we add those together, the negative 2y plus 2y, that gives me 0. Z minus 2z is negative z. And 6 minus 12 is negative 6. So I'm going to rewrite this whole thing out. And I'm kind of separating these systems of equations so we don't get confused, okay? So we didn't change anything in the first 2 rows here. And now but the third row is now negative z is equal to negative 6. All right, guys, this is looking good. I don't have anything under this x right here, and I don't have anything under that y. That's good. Now, the only thing I need to change now is we want the coefficients to be 1. So what I'm going to do now is I am going to divide row 2 by negative 2. We don't want to have a negative 2 in front. And then on this third row, we're going to divide by a negative because we don't want it to be negative. We want it to be positive. So I'm just going to put a little note here. So I'm going to make a new row 2. What I'm going to do is I'm going to take our current row 2 and divide it by negative 2. When I do that, what I'm going to get is negative 2y divided by negative 2 is going to be just y. Okay? But then, well, you know what? Let me show some work here, okay? So I'm going to take my original equation, negative 2y plus z is equal to 6. I'm going to divide all of these by negative 2. So when I simplify this, I'm just going to get y minus 1/2 z is equal to negative 3. All right. Also, while I'm at this, I'm going to take row 3, and I'm just going to divide it by a negative 1. I guess I could times it by negative 1. Either way is good. All that's going to do is it's going to change it from negative z equals negative 6 to z equals 6. Okay, so now let's write this out. We're basically there, guys. So the first row we're already done with. That's x minus y plus z is equal to 5. In the second row, we have y minus 1/2 z is equal to negative 3. And in the third row, we have z is, oh, what was that? Z is equal to 6. And voila, this is upper triangular form. And this is awesome because it allows us to solve our system of equations. Let me show you what I mean. So to start off, we know z is 6, right? Well, now let's plug that into our second equation, okay? Our second equation said y minus 1/2 z is equal to negative 3. Well, now instead of z, I'm going to plug in 6. So this gives me y, and then I'll have negative 1/2 times 6, okay? That's going to be half of 6 is 3, but it's negative 3 is equal to negative 3. When I add that 3 over, I get y is 0. So now I've solved for x, y, and z, sorry, I've solved for z and y. Now I need to plug those into our first equation, and we'll get x. So the first equation says x minus y plus z is equal to 5. What I'm going to do is I'm going to plug in that y is 0 and that z is 6. And then I can solve for x. And I get x plus 6 is equal to 5. And when I subtract that 6, I get x is equal to -1. So my solution to this system of equations is -1, 0, 6. So this had one solution, which means that this is a consistent, independent system. Because if I were to go back to our original notes here, or the introduction, we said consistent means it has at least one solution, and if it has just one, it's independent. So this is an independent, consistent system. There's just one solution, and that's how we found it. All right, now, that was your first time seeing this. Do you have any questions on what my steps were? Basically, I went through and made it. So I got rid of, I got it into upper triangular form, so it's like that. So I'm going to pause now, and I'm going to look at you guys. Where are you? There you are. Do you have any questions on what I just did?
How did row 1 turn into x minus y? Like, where did the 3 go for the leading coefficient?
Okay, so the very first step I did here, Emily, was I switched row 1 and row 3. So if you look over here, row 3 was a 3x minus y, and then it was x minus y was row 3. I just switched those spots. So this one came down to here, and this one went up to there. Does that answer your question, or was it something different?
That was the question. Thank you.
Awesome. Cool. Any other questions, guys? And if you're like, I'm just all sorts of confused, well, we're going to do a lot of examples, okay? Now, one thing I want to bring up, how do I check my work? It's important that when you're doing this, you check your work. So what you're going to do is you're just going to plug in your numbers, and it should give you a true statement, okay? So if I'm looking, remember my solution was -1, 0, 6. If I were to plug those into the first equation, let's look at that. Plug in -1, I'd get -3. Plug in 0, you get 0. And plug in 6. Is -3 plus 6 equal to 3? Yes, that's a true statement. Let's go to the next one. 2 times -1 is -2. 0 times 4 is 0. And then 3 times 6 is 18. Is -2 plus 18 16? Sure enough, that's a true statement. Looking good. Lastly, we're going to have is -1 plus 0 plus 6. Is that equal to 5? And it is. So that's how you check your solution. You have to check all the equations, and it worked. Huzzah. Okay, cool. Now, as we've been doing this, it gets a little tedious. Like, if I go back and I look at this, that's a lot of like, I really didn't need to write out the x's and the y's and the z's. I could have just kept the numbers and had them in the right column, because the first column was your x's, the second column was the y's, and the third column was the z's. And whatever it's equal to, that was on the far right. So it's easier to do this if we actually switch it into a matrix. Now, you probably haven't worked with matrices, that's plural a lot, but a matrix is a rectangular array of numbers. You basically just put numbers in a rectangle. And it actually works out like if you look at this first, oh, I didn't mean to do that. What did I just do? There we go. Sorry. If you look at this first row, and I look at my coefficients, notice all the x's line up, all the y's line up in the same place, all the z's line up in the same place, and it's all equal to a constant. What I'm going to do is just take the coefficients and write them out there. And then I'm going to take the coefficients from my second row to -4, 3, 16, to -4, 3, 16. And lastly, when I come down here for that third row, we have x minus y plus z is 5. We'll just look at the coefficients. That's 1, -1, 1, 5. And notice where the equal sign is, we put just a little line there. That line is going to represent our equal sign. This is called an augmented matrix. So there's our equal sign, it's the line. Okay, an augmented matrix is basically a system of equations in a matrix. It's an equation because there's an equal sign. And we're going to go through those same steps at what we just did, but now we don't need to write x, y's, and z's. We're just going to keep them in the right column and we are good. Okay, so when we get this into upper triangular form, but with just numbers, we're going to call that row echelon form. Okay, so row echelon form is where the first non-zero entry of each row is a 1. The leading one of a given row must be to the right of the leading one of the row above it, and any row of all zeros cannot be placed above a row with 0 entries. So basically, if I look at this guy that was triangular form, this was in a matrix, this would be 1, -3, 2, 1. There was 0 for the x, 1, -2, and then a 4. 0, 0 for the x and y, then 1, -1. This augmented matrix here, this is in what we call row echelon form. And it's the equivalent of upper triangular form. We like it because it tells us that z is -1. Then I can plug it in and figure out what x or y is. And then I can plug it in and figure out what x and y is. So moving forward, our goal is to get it to look like this. It's the same strategy we did before, but it's less writing. We don't have to worry about writing all the x, y's, and z's. We just keep it in the right column. This represents your x coefficients, y's, z's, and what they're equal to. All right? So we're going to have the same rules that we can do. We can still just switch the rows. We can multiply or divide them by a constant as long as it's not 0. And then we can do those combination of rows after we multiply them, just like what we did before. Now, we're going to try that out with this right here. Before I do you have any questions about like switching it over to an augmented matrix or what row echelon form is? All right, if not, then let's go through and do an example here. Okay, so what we're going to do first, here's our system of equations. We're going to change it into an augmented matrix. When we do that, what we're going to do is we are going to rewrite it where we have the x's in the first column, the y's in the second, and then it's equal to the third. We're just looking at the coefficients. So what this will look like is I'm going to have 2, 3, 6, 1, -1, and then 1/2. Like that. We put a line where the equal sign was. Now, what our goal is we want it to look like this. We want to get a 1 here, a 0 there, and a 1 here. Now, we could still have something here. I'll just call that A, B, and C, right? But if I get it to this point, it tells me that C is equal to whatever it's going to be, right? Or not C, I'm sorry. This will tell me that this is Y is equal to whatever that constant is. And I can plug it in so I can figure out X. All right, so let's go through. We're going to do the same thing we did last time, except now we're going to use matrices instead of a system of equations. We're going to find it's actually a little bit faster and easier. All right, now I'm going to do the same thing I did last time with my first step. I'm going to switch row 1 and row 2. Looking at them, row 2 starts with the 1, and my goal is to get a 1 up top. So I'm just going to have them switch spots. So I get 1, -1, 1/2, and then 2, 3, 6, like that. Now, I need to get rid of that 2. I want that 2 to become a 0. So to do that, I want to think in my brain, what's the opposite of 2? And you would say -2. So what could I times this 1 by to make it -2? And the answer is -2, right? So I'm going to put a note. I'm going to make a new row 2. To do that, I'm going to times row 1 by -2. Because then when I add it with row 2, it's going to give me 0 in that first column. Let me show you what I mean. Let's times row 1 by -2. It gives me -2, +2, and then -2 by 1/2, that's just -1. Now row 2, we're not changing, it's just 2, 3, 6. Let's add those together, and we are going to get 0, 5, and 5. Nice. We like that, right? So let's put that back into our equation, or into our matrix here. So this gives me, the first row didn't change. We just got a new row 2. Now I have 0, 5, 5. Hey, we're pretty darn close here. We have a 1, a 0. Now we just need to get the other one to be a 1. And the way we're going to do that is just divide it by 5. So I'm going to come here and say, let's get a new row 2 again. But this time what we're going to do is we're going to take our existing row 2 and divide it by 5. When we do, that's just going to turn it into 0, 1, 1. So again, the numerator, call it numerator, the top row doesn't change. The bottom row is now 0, 1, 1. And this is our goal. Remember, we wanted to get 1, 0, 1. We've got that. And the reason why we like that is because now we need to interpret what's going on. What does this tell us if I have 0, 1, 1? Well, this means that if I take 0 x's and 1 y, that will, sometimes it does that. 0 x's and 1 y, it will equal 1. So write it out as a system of equations now. I know that y is equal to 1. Woohoo! Then if I rewrite out my first equation, it'll be x minus y is equal to 1/2. Well, we just found out that y is 1. So x minus 1 is equal to 1/2. So I'm going to add 1 on both sides. And that gives me x is 1 plus 1/2, which would be 3/2. So my solution to this system of equations, x is 3/2 and y is 1. So again, this would be a consistent, independent solution because it has one solution. Okay? Now let's check our work before, and then I'll open it up for questions. So what we're going to do is let's come back to the very beginning here, and let's plug in x is 3/2 and y is 1. So if I look at 2 times 3/2, that's going to give me 3, because the 2's cancel, and then plus 3 times 1 is 3. Is that equal to 6? And yep, that's a true statement. Let's look at 3/2 minus 1. Is that equal to 1/2? And yep, it is. Awesome, it works. Okay, hit the pause button again. Do you have any questions on my steps on this example? Any questions on like the steps or why I did what I did or how I got anything? All right, if you do, please stop me because I'm just kind of talking to myself here. Okay, now we're going to change this to a 3 by 3. All right, so there's 3 equations, 3 variables. What I'm going to ask you guys to do is I want you to start off by just converting that into an augmented matrix. So just like what we did on this example here, where I took it from having x's and y's to then being a matrix, I want you to do the same there. So I'm going to give you 30 seconds, and then I'm going to call on a person, not telling you who, to tell me what they got, okay? Go. All right, Jenna Lee, will you tell me how you wrote that out, please?
So the first row I wrote -1, then -2, 1, and then across the line is -1.
Okay.
And then the second row is 2, then 3, then 0, and then across the line is 2.
Great.
And then the third line is 0, 1, then -2, and across the line is 0.
What do you guys think? That's spot on. So thank you, Jenna Lee. Hey, that's kind of a big deal though, because if you write the matrix wrong, which people have done before, they'll switch it up, like put it in the wrong column, then the whole rest of the problem is done. You could do perfect operations, but if you don't convert it right, then it's just your GG apparently. Okay. All right. Now let's go to the next step. So our goal on this one, guys, is we want this to look like row echelon form, which means I'm going to have ones on the diagonal like this with zeros underneath them. Now, we don't care if there's stuff going on here, right? That's okay. That's going to help us figure out our solution, but we need to make those become 1, 0s, and 1s. So my first question for you guys is, what's a good first step? What would you guys like to get done? What would you guys do first here? Any guesses or any, and sorry, let me interject with something first. With these, there's not a set way you have to do this. There's many different ways you could go through to get it to where it needs to get. So there's not really a right or wrong answer. But does anyone have any thoughts or any ways they want to do this?
Why don't we start off by taking the second row and changing the x to 0?
Okay, yes. We want to make this guy become a 0. Cool. Now, one thing I'm going to do before that is I'm just going to take this row 1. I want it to be a positive 1. So I'm just going to get that to be, times it all by a negative first, and then we'll be good. And then that'll be our next step. So thanks, Calvin, for sharing your thoughts here. So let's go through and let's go through some steps here. And if I lose you at some point, please just stop. So what I'm going to do is I'm going to start by getting a new row 1. I'm going to, and I don't have to divide, I'm just going to times it. So I'm going to do negative times R1. Okay? And that'll just change all the signs. So now this is going to be 1, 2, -1, and then 1. Because I want to see a 1 out in front there. Now, let me show you another trick that maybe you didn't see there. But when I'm looking, okay, so pause. Let me actually just ask you a first question. So when I'm writing here, it shows me a little cursor. Like right now, where that -1 is, I'm circling it. Can you see this circle, me circling this with the cursor, or does it not show you the cursor?
Yeah, we
I can see the cursor.
You can see me go in a circle, perfect. That makes life easy. Okay, so just want to make sure. So guys, I want to get a 1 here, but my next step after that, get zeros, I'll also want to get a 1 here. And if you notice right there, there's just a 0 and a 1. So what I'm also going to do is I'm going to switch row 2 and row 3. Because then that sets it up so I get 0, 1, -2, 0. And that's kind of just giving me a head start for the next column. Now, if you're like, well, I wouldn't have thought of that. Well, then it's okay. You still will get to the right place, okay? It's just you're going to pick up some tricks along the way to make it easier to get there. So I times row 1 by a negative, and that got it to be a positive 1, and then I just switch row 2 and row 3. Now let's do what Calvin originally said. Let's get rid of this 2. Calvin, I want you to unmute. How would you get rid of that 2?
You would multiply it by a -2.
There you go. And now the only place we can get a -2 is from row 1. We'd have to times that 1 by a -2, right? So I'm going to get a new row 3. The way I'm going to do that is I'm going to times -2 by row 1, and then add it to row 3. All right, let's do that here. I'm going to do that in a different color. So -2 times row 1, that is going to be -2, -4, +2, -2. And then row 3 isn't changing. That was just 2, 3, 0, 2. When I add these together, I get 0, -1, 2, and 0. So now I'm going to go and rewrite my matrix, but with that new row 3. If you haven't caught on already, these take up a lot of space and there's a lot of writing, and I suggest that you just do it, okay? Like, don't try to like take shortcuts because you're going to mess up. Just take the space, write it out, and it's better to do it right with a lot of work than to do it wrong taking shortcuts. Okay, so now our new row 3 is 0, -1, 2, 0. Awesome, awesome, awesome. Okay, now what we're going to do is I'm going to try to get rid of this -1. The opposite of -1 is +1. So if I just add these together, I'll get 0. So I'm going to make a new row 3 again by adding row 2 and row 3. Okay, so when I do this, I'm going to have, I don't need to really worry about the zeros, but we can write them anyway. So 0, 1, -2, 0, and 0, -1, 2, 0. We're going to add those together. 1 minus 1 is 0, -2 plus 2 is, and uh-oh, 0 equals 0. What is going on here? I'm going to hurry and just write that out as my next step. And while I'm doing that, I want you guys to think based on what you did from 6.1 and 6.2. What does it tell us if we get 0 equals 0 while we're going through this process? All right, someone unmute and tell me what it means if we get 0 equals 0.
Does that mean it's going to be inconsistent?
It's going to not quite. So inconsistent means there's no solution. And that's a great guess, but it's actually going to be the opposite of that. So what would be the opposite of that, Calvin?
It would be consistent.
Yeah, so 0 equals 0 is a true statement. Now, when you were working in 6.1 and 6.2, if you were solving and it kind of canceled out but gave you a false statement, then it meant there's no solution. But if you're solving and it cancels out but it gives you a true statement, this means there are infinite solutions. So it all depends on if it cancels to a true or a false statement. Using our vocabulary words, okay? So this is still a consistent solution because it has more than, it has at least one solution. But since it has infinite solutions, we're going to call this a dependent. So it's consistent and it's dependent. Now, let me show you a picture of what this could look like, okay? When you have a system of 3 variables, so an x, y, and z, it makes a plane, which you can imagine just kind of like a rectangle here, but it's going like, it's going up, down, left, right, like infinite, okay? Think of like a wall that just always goes up or down, but it's got a direction. Now we've got 3 planes here, but they intersect along this line. So how many solutions are there? Well, I could take a infinite number of points along that line and it would be a solution to this system. Okay, does that make sense to this point? We're not done yet, and I'll tell you why in a second, but does that make sense how we got 0 equals 0, and that means that there's infinite solutions? Do you have any questions? All right, well, you're not done because, so basically if you were to solve this on like a final question or on a test, most of the time, just putting that there as infinite solutions will get you full points. But sometimes they're going to ask you, hey, I want to know the equation of this line. Okay, I want to be able to come up with the points that would be considered solutions. Okay, and what you're going to do there is you're going to come up with that by using another variable, which is called t. And the vocab word we're going to use here, it's called a parameter. Okay, so we're using a parameter t, and it's basically just another variable, but we're going to use t to help us figure out solutions to this. Okay, now what I'm going to do is I'm going to replace anywhere that we saw z with a t. For example, so let's go back to this equation right here. Okay, if I were to write this out using x, y's, and z's, this would say 0x, so we're not going to write that. We're going to have y minus 2z is equal to 0. Now, what we're going to do is we're going to solve for y, but we want it to be in terms of t. So first off, let's replace the z with the t. And we're going to solve for y. Pretty easy from here. We're just going to add 2t on both sides. And that tells us that y is equal to 2t. So z is t, and if z is t, then y is 2t. Now, let's go to the first equation right here. And we're going to write it out in x, y, and z, but wherever we see a y, we're putting a 2t. Wherever we see a z, we're putting 1t. Okay? So I'm going to write this as, it was x, oh, sorry, we don't want that. X plus 2t, or sorry, x plus 2y, we're going to keep it in terms of this case, sorry. X plus 2y minus z equals 1. But since y is 2t, we're going to write that as x plus 2 times 2t minus z is just plain old t is equal to 1. All right, let's simplify that. That's x plus 4t minus t is equal to 1. 4t minus t is just 3t, so that's x plus 3t is equal to 1. So I'm just going to subtract that 3t on both sides to solve for x. So x is 1 minus 3t. So if we wanted to come up with a way of getting points, the x values would be 1 minus 3t. The y values would be 2t. And the z values, it would just be t. And if you're like, Solberg, that makes no sense. Well, stay with me, okay? Let's just plug in values for t. So if I'm going to let t equal 1, okay? T equal 1. Then what does that mean x is going to be? Well, 1 minus 3 times 1, so 1 minus 3, that's negative 2. And if I plug in 1 there, 2 times 1 is 2. And if I plug in 1 there, I just get 1. So this point, negative 2, 2, 1, that is a point on the line where all three of those intersect. So we have 1 point right there, okay? Well, what if I wanted to get another point? Well, then let's just come up with another t value. Let's let t equal 2. If t is 2, then 1 minus 3 times 2, that's 1 minus 6. We get negative 5. 2 times 2 is 4, and then 2. So this would be another point on that line. And I could just keep plugging in points for t, and it would keep giving me points that are on the line where all three of those planes intersect. All right, that was a toughie, okay? Do you have any questions on it? I'm going to stop for 10 seconds. If you have a question, please speak up.
Can you use any number for t?
Yeah, you could plug in any number, and basically that will tell you, it'll give you an X and a Y, because on this line, there's going to be an infinite number of solutions, and they're all based off of Z, which is T, right? And so if you just plug in different values of Z, it will tell you what values of X and Y correspond with that. Great, thanks for asking a question, Calvin. Any other questions? All right, well, I think we only have 2 more examples. So if you guys can just hang in there with me, all right? I know this is taking a little bit longer, but I hope that you're understanding. If not, please speak up. Okay, so reduced echelon form, or sorry, we talked about row echelon form. That was when it's going to look like this one. Row echelon form is where we have the ones on the diagonals and zeros underneath them. Now, reduced row echelon form, that is where you're going to have ones on the diagonals and zeros above and below them. So if I'm looking at this first matrix, this is a system of 2 equations. So I have 2 equations, 2 variables, ones on the diagonal, zeros underneath. And this is good because this tells me X is equal to that number, or sorry, Y is equal to that number, X is equal to that number. If it's a 3 by 3, well then we like it because Z is that number, Y is that number, X is that number. So we don't have to do any converting back into X and Y's. It just gives us that, okay? So we like reduced row echelon form, but it's a little more work. So we're going to go through how you're going to get this into reduced row echelon form, okay? Now, I start off, let's go back here. Notice that this has numbers, and the numbers are going to tell you the order to do this in. So if it was a 2 by 2, you would start by getting a 1 here, and then you'd get a 0 beneath it. Then you'd get a 1 here, and then a 0 there. So you're kind of going in a circle like that. In this next one, you're going to go in this order. So first, second, third. So you get the 1, 0 underneath it. Get the next 1, 0 underneath it, and then get the 1. Then you get a 0 above that, 0 over here, and then 0 there. So this is telling you the order to go in. If you go out of order, you end up undoing some of your work. So let's say you got like a 0 somewhere. Well, now, since you went out of order, there's no longer a 0 there, and you have to go and undo it. Let's do an example of this, okay? So first off, here is our system of equations in X, Y, and Z. We want to change it into an augmented matrix, all right? So I'm going to ask, let's have Spencer Taylor. Could you speak up and tell me what that would look like as a matrix what that system of equations would look like as an augmented matrix?
Yeah, so your first row would be 1, 1, and 1, and then 4. And then row 2 is 2, -1, 2, and then -1 on the other side of the line. And then row 3 is 1, -2, 1, with the 1 at the end.
Okay, thank you, Spencer Taylor. So now, when you're doing this, what I would do, guys, is I would pause and double check it. Make sure you have, if there's a negative, the coefficient needs to be negative. Does this look right? Take that extra second to check it, because you don't want to like spend 20 minutes on a problem and like get super frustrated because you copied it down wrong or converted it into a matrix wrong. Okay, here we go. So if we're looking back at our steps, our first step was to get a 1 in that upper diagonal, and guess what? We already got it. So then our second step is to get a 2 there, and then we want to get a 0 here. So I'm going to ask Emily Sandoval, how am I going to get a 0 where the 2 is? And then Caitlin Shamo, how am I going to get a 0 where the 1 is? Emily, what are we going to do?
We're going to multiply a row by -2.
Uh-huh. And then add it with it, right? Awesome. Thanks, Emily. So we're going to make a new row 2 by taking row 1 and timesing it by -2. That'll cancel out the 2. And then just adding it to row 2. Let's do that, and then we'll get to Caitlin. So -2 times row 1 is going to be -2, -2, -2, 4. Wait. Sorry, not 4. -8. That's a common mistake, is you just keep the end the same. No, multiply everything. Okay, now row 2 is 2, -1, -2, -1. When I add that together, I'm going to get 0, -3, -4, -9. Okay, Caitlin, are you there? Can you tell us what to do to get that row 3 to have a 0?
You multiply row 2 by 1/2.
Yeah, you could. You could, so if it was -1/2, right? And then you would add it to it.
Yeah, sorry.
So that's one way you could do it. And you could definitely do it that way. But the only downside to doing it that way is then you're going to have fractions. I don't like you, I'm not a big fan of fractions. So could I maybe use row 1 instead?
Okay, yeah. So then you just times it by 1.
Or by -1, right?
Well, -1, sorry.
Awesome. Thanks, Caitlin. Awesome. So yeah, and this just goes back to there is no right or wrong. Well, there's definitely wrong ways to do this, but there are multiple right ways you could do this. So try it out. There's not like a set, you have to do it this way. And if you want to try something, go for it. Okay, I usually just try to avoid fractions when I can. All right, so I'm going to do negative row 1 and add it with row 3. So when I do this, I'm going to get -1, -1, -1, -4, and add it with 1, -2, -1, 1. That's going to give me 0, -3, -2, -3. Okay, cool. So now let's rewrite our matrix. All right. Any questions up to that point? Does everything still look okay? Okay, so now if I go back, I've got that first row taken care of. That's pretty cool. My next step is to make that a 1 and then a 0 beneath it. Now, in this case, I would just divide by a -3, and that would make it so it's a 1. However, thinking ahead a little bit, I'm going to need to make this become, I need to cancel that out next. And so what I'm going to do here is I'm actually going to cancel that out first, just because, I'm going to have to times it by 3 again, right? So I don't want to divide it by -3 and then times it by 3. Like, it's just kind of redundant. So I'm trying to save myself some work here, okay? So let's just look at this right here. How would I cancel that -3? I would need to times by a +3. Now, this brings up a good point. Someone might say, why not just use row 1 times row 1 by 3? Well, when you add it, then you would have to add this here, and then that's going to get rid of that 0, and that's making you go back and do more work. So don't use row 1 when we're canceling here, or else we're not going to have the zeros out in front. So I'm going to do this one real quick. I'm going to get a new row 3. The way I'm going to do that is I'm going to take a negative row 2, and then I'm going to add it to row 3. So if we just rewrite row 2, but times everything by negative, that just makes everything positive. And then we're going to keep row 3 the same. That's 0, -3, -2, -3. Add those together, we get 0, 0. This is going to be 2, and this is going to be 6. Okay, cool. Now, I'm going to come back to that. Well, I'm trying to save how much we have to write here. For row 3, I'm going to want that to be a 1. So what if I just divide this whole row by 2, that will save me a step of rewriting the whole fraction, okay? So I'm going to actually put just another side note here. Hey, while we're at it, let's just divide row 3 by 2 so that we can get it to be 0, 0, 1, 3. That will just help us in this process, okay? Now, what I'm also going to do is I need that this middle -3, I need that to become a 1. So I'm going to get a new row 2. I'm going to take our original row 2 and divide it by -3. And yeah, that means we're going to have fractions. I'm sorry. Because if I take all of these numbers, 0, -3, negative, oh, let's do this in blue. Sorry. I'm trying to keep with the color scheme here. But if I take 0, -3, -4, -9, I'm going to divide all of those by -3. That's going to give me 0, 1, 4/3, and 3. Now that's row 2. So let's rewrite our matrix now. Top row did not change yet. Our new second row was 0, 1, 4/3, and 3. And then our bottom row is 0, 0, 1, 3. Now, awesome job, guys. We got it into row echelon form. And we could convert it into a system of equations, convert it back, and then solve. However, this is asking us to get it into reduced row echelon form, so we want zeros above the diagonal as well. So if I go back and I look at this, we have now gotten to step 6, so I need to get a 0 here at 7, 0 at 8, and then 0 at 9, okay? So let's see if we can figure out how to do that, okay? So if I want, so now my focus is on this 4/3, and I want to cancel it. Now, I'm not going to use row 1 to cancel it, or it's going to put 1s back in our very first column. So I'm going to use row 3, and I'm going to think, hey, what would cancel 4/3? And you would say a -4/3, and you're so smart. Good job. So what I'm going to do is I'm going to get a new row 2. The way we're going to do that is I'm going to take our regular row 2, and we're going to add it with row 3, but I'm going to times row 3 by a -4/3. So row 2 is currently 0, 0, 1, 4/3, 3. And I'm going to times row 3 by a -4/3. And when I times -4/3 by 3, they go away like that. The 3's cancel, so it's just -4. Okay, so I'm going to add these together. And I'm going to get 0, 1, 0, -1. Awesome, awesome, awesome. So what that tells me is that the second row is going to look like that. So I got rid of that -4/3. Now, to kind of save some space here, I'm also going to focus my effort on that one next, okay? However, I can't use row 3 to get rid of it. I'd have to use row 2. Well, we just changed row 2, so let's actually take the time to rewrite this first, okay? So my first row is now 1, 1, 1, 4. My new row 2 is 0, 1, 0, -1. And then the row 3 is still 0, 0, 1, 3. Okay, so now I'm actually going to change my, let's do this. I was going to try to move select. There we go. There we go. We're going to just now focus on that one. Wait a minute. How come no one's yelling at me? This is supposed to be a 1. You're supposed to yell at me if I make a mistake. Okay. All right, so now I'm going to actually call on Nathan House. Nathan House, how am I going to get rid of that 1 here? Which row would I use and what would I do with that row?
I have no clue.
Well, looking at the rows, what is the only row that has a value in the second column?
Row 2.
Yeah, so I can't use row 3, right? Because there's nothing there, so I have to use row 2. Good. What's the opposite of 1?
0.
No, what would make it turn into 0 is what we're going for. So the opposite of 1 would be,
-1.
yeah, so all I'm going to do here is I am going to times, I'm going to get a new row 1. The way we're going to do that, row 1 stays the same, but then I'm going to basically add a negative times row 2. And some might say, why not just subtract it? I find it's confusing that way. People forget to distribute negatives. So I just add it. I'd make sure I times it by a negative first. So I'm going to do row 1 is 1, 1, 1, 4. And now I'm going to times a negative to row 2. So it's -1 and then +1. So when I add those, I get 1, 0, 1, 5. And that's our new row 1. And oh, we are so close, guys. We've got 1, 0, 1, 5. Everything else is the same. Okay, last one on here. I need to get rid of this one. I just need someone to speak up and tell me what would they do to get rid of that 1. That's our last step. Fine, I'll just call out someone. Okay, Lucky, I'm calling you out. How would I get rid of that 1 I just circled in green?
You would use row 3 and multiply by -1.
Awesome, thank you. Okay, so the row 1 right now is 1, 0, 1, 5. And then I'm going to do a negative, so 0, 0, -1, -3. So I get 1, 0, 0, 2. So now can write out my finalized matrix. It is in reduced row echelon form, which is nice because it tells me right off the bat that z is equal to 3, y is equal to -1, and x is equal to 2. So my solution is 2, -1, 3. This would be a consistent, independent system. There is only one solution. And that's how you do it, guys. Do you have any questions on that example? You're probably burned out, and I'm sorry. This is the toughest lesson of the year, and that's why I wanted to make sure I went through it. And there's one more example, but guess what? It's actually one of the easier ones. So let's just wrap this up real quick. Looking at this, I have 4 variables now. They ran out of variables after X, Y, Z, so they decided, let's just go back to A, B, C, D, and there's 4 equations, so we could solve this. And it's actually pretty darn easy. But what I need you to do is I want you to write this out as a matrix. But now, instead of doing X, Y, Z, we're just going to do A in the first column, B in the second, C, D, and then the number. Clayton, can you tell me how to write this out?
Would it be 1 in the first, and then 0, 0, 0, and then 1?
Yep, keep going.
It would be 0 in the second, first, and then 1, 0, 0, 0, and then 3, 0, 1, 0, and 5, and then 0, 3, 0, 1, and -1.
Yes, thank you, Clayton. So that's the first step, right? Just make sure you get it looking in the right steps. Now, as I'm going to go through this, I'm going to say, let's look at the first column. I need to get rid of that 3. And kind of using the steps that we've done before, let's just say, all right, I need a new row 3. The opposite of this 3 right here is -3, so let's just do -3 times row 1 and add it with row 3. When I do that, I'm going to get -3, 0, 0, 0, -3. We're going to add that with 3, 0, 1, 0, 5. When I add those together, I get 0, 0, 1, 0, 2. Okay, so now I know that's a big, ugly matrix, but we're going to rewrite it just because sometimes when you try to do too many steps, you make mistakes. Actually, you know what? Okay, fine. I already said it. So 1, 0, 0, 0, 1, 0, 1, 0, 0, 0. And now we just said this one is 0, 0, 1, 0, 2. This is looking great. Now I'm going to change my focus to the second column. The first column's good. I need to get rid of that 3. The only other row that has something there is row 2. So I'm going to times row 2 by -3 to cancel that out. So I'm going to get a new row 4. To do that, I'm going to do -3 times row 2 plus row 4. So -3 times row 2, that's 0, -3, 0, 0, 0. And then row 4 is just 0, 3, 0, 1, -1. When I add those together, I get 0, 0, 0, 1, -1. So rewriting this out, first row did not change. Second row did not change. Third row did not change. The last row is now that. And there we go. Is this thing in reduced row echelon form? I only see 1s and 0s, so what that tells me is that A is 1, B is 0, C is 2, and D is -1. So my solution is 1, 0, 2, -1. Once you get into 4 systems of equations, it's hard to visualize what's going on because it's into the 4th dimension, which I don't know how to do that. But this would be where all 4 of those intersect. All right, now that's going to do it for today. So let me jump back to where I can see you guys. First off, thank you for tuning in today. I hope that's helpful and that makes sense. What I need you to do is start doing the homework. And if you get stuck, to just send me an email. I think the easiest way for me to do this is that if you send me the problem, then I can like work through it on like a Loom. I'll make a video tutorial and then I'll just send it out to everyone. Before I let you go though, do you have any questions on any of the problems that we've been doing today? Let me change that because I haven't got much of a response. So what I need you to do is just either put it in the chat or just say it. I want you to give me like a fist of 5 of how well you feel about these problems. Of 5 being a pro, 1 being that you're like, I'm totally lost. So if you'll just unmute and give me a number 1 through 5.
4.
Awesome.
3.
4, 4, 4, 4.5, 3.5. Awesome. Great. That makes me happy to see that. If you have questions and you want to stick around, that's great. I only have a couple minutes till my next class starts. I'm sorry that took so long, but I hope you're feeling good. Remember, your credit card debt project is due today. Over Thanksgiving break, I need you to wrap up Chapter 5 homework and get caught up with Chapter 6 homework. When we come back, we're going to finish 6, take your test, start 7, and then it'll be Christmas break, and then we'll have your final. So it's going to be here before you know it. So again, thank you. You guys are awesome. Let me know if you need help, okay? And enjoy your Thanksgiving break. Stay safe.
Thank you.
Thank you.
You're welcome.
Mr. Silver?
Thanks, Silberg.
See you, Caitlin. Have a good break.
Mr. Silver,
Yes, Clayton.
help me on the project that we have. I just had a question on number 5 and how we solve for M.
On how to solve for M. If I'm thinking of which one, whoa,
It's like an equation with like P equals like, and then that, and we have to solve for the M. So that we make a new equation, and I just got stuck on that.
gotcha. Okay, so real quick, if I were to, let me pull up a new screen here. So I believe it's something like this, P equals, and there's like something in the numerator, and it's like 1 plus I to the M, or something like that, right?
I can't see. Wait, did you?
Well, am I not sharing my screen with you anymore? Sorry, let me. Okay, can you see what I'm doing now?
Yeah.
This looks something like that. It's not the exact same, but something like that, right?
Something like that, yeah.
Okay, so what you need to do is first get rid of this over here, okay? So that's 1 plus I to the M. And you're timesing that on both sides. That's how you get rid of it, okay? So goes away. So now I've got 1 plus I to the M P is equal to Z, something like that. Well, now divide by the P to get rid of that, okay? So the P's go away, so I have 1 plus I to the M is equal to Z over P. Well, we want to isolate that, so subtract 1. So I get I to the M is equal to Z over P minus 1. Okay, so when you get it to this point, how do you get a variable out of the exponent? Thinking this is chapter 4, right? So one of the big things we did was solving exponentials. And what did we use to solve exponentials?
The log and stuff.
There you go. So I would convert this to a logarithm where I'd say log base what? What will the base of this log be?
Is
It's going to be the
I.
I. Yeah, it's the base of whatever the base of the exponential is, the base of the log. And then this, was that a 7 over P minus 1? That's going to equal M. So basically, you isolate your exponential, you rewrite it as a log, and that's how you're going to solve for M.
Okay.
Does that make a little bit of sense?
Yeah.
Awesome. If
Thank
not,
you.
just send me an email.
Okay. Thank you.
You're welcome. See you, Clayton. Nathan, you have a question? Or are you just hanging out?
Just watching.
Okay.
It's like I also had trouble with 5. Like I was able to get to that form, but then every time I tried solving it, it told me that like the denominator was bad or whatever.
I think you just have to send me a picture of it.
Okay.
Could you email me that? And then I'll try to help you from
Yeah.
there. Okay. Awesome. Thanks, Nathan. Have a good break.
You too.